So continuing with our SAT practice, welcome to the final practice of the first practice test that the College Board has available. After this, of course, I'll go into the second, well, actually the third. I'll get back to the second practice test, but we will continue going. As a reminder, for all of the problems, I recommend pausing the video and attempting the problem before watching the solution. And as another reminder, at the end of both math forms of the SAT, there are these student response forms where you basically solve the problem and then write your answer here. You can make fractions, you can make decimals, you cannot make negative numbers, and you cannot use more than 4 characters. So give this problem a shot. Okay, what we have here, we have a cylinder, and it says a dairy farmer uses a storage silo that is in the shape of a right circular cylinder. These are all terms that are important to make it exact, but for our purposes, we're not going to be dealing with non-right prisms or cylinders on the SAT. We're not going to deal with elliptical extruded solids, but they're important mathematically to have those words there so no one can come back and argue about the meaning of the problem. It says the volume is going to be 72 pi. What is the diameter of the base of the cylinder in yards? Now, don't forget, you have a formula sheet at the beginning of this section. Flip back there, look for a cylinder. You will see the formula, V equals pi r squared h. If you need it, you should have it memorized, but if you need it, it's right there. And now, I'm just going to go through and solve this off. Now, notice I don't have diameter yet. We'll get back to that, but I'm going to plug in what I know. So I know that the volume is 72 pi. I'll replace the volume with 72 pi. Pi is a constant. I don't need to substitute anything in for that. I have nothing in here that tells me what the radius is, so I'll just have r squared here, but I know that the height is 8. And I'm just going to divide. Now, I want to get the radius by itself first. So I'll get rid of the pi and the 8. Pi's cancel, pi's cancel. 8's cancel. 72 divided by 8 gives me 9. So 9 is r squared. To get rid of the squared, I take a little square root. The square root of 9 is 3. Algebraically, r could be plus or minus 3. But since we are talking about a solid and measurements and lengths, I take the positive 3. Finally, what we found is this length here is 3. But we want to find the whole length across, which will be twice as long. So the diameter is going to be 2 times the radius. 2 times 3 gives me 6. All right, give this problem a shot. Okay, so I need to find for what value this is undefined. And this might look very technical, very tricky. It's not. So if you've done work with rational functions or fractional expressions, rational expressions, whatever, you'll know that the only time that this, I say, sort of goes bad is when the denominator, the bottom expression, equals 0. Figure out when that happens, you've got your answer. So I basically need to solve the equation 0 equals x minus 5 squared plus 4 times x minus 5 plus 4. Okay, now, next thing. Someone might jump to saying, they might have seen the video I put up earlier, someone saying, hey, I have this x minus 5. It looks like a factor, so 5 should work. That's not the case. There's this 4 here. Probably the simplest way to do this, which isn't unfortunately as fast as I would like, but it would be to expand out both of these terms. So I would have x squared minus 10x plus 25 from this. I would have, by distributing the 4, 4x minus 20, and then I have this plus 4. I'll bring everything together, so I have x squared, I have minus 6x, I have plus 25 minus 20 plus 4, which is going to end up giving me a plus 9. And when I factor this, I actually get x minus 3 times x minus 3, or x minus 3 squared. So, in here, if you remember, if the factor is x minus 3, then the solution, or the 0, is x equals 3. Or you could do zero product property and say, okay, x minus 3 equals 0, or x minus 3 equals 0, add 3 to both sides. So the only thing that works out here is 3. Now, a little bit of a rundown on factoring. So the way I usually did it is I just use my mental math to say, okay, I know I have these two terms, and I want to get it to work out this way. So let's see, what will multiply to 9? Well, 3 and 3 does, but a plus 3 and a plus 3 gives me a plus 6 here. So I actually have a minus 3 and a minus 3. That's sort of one way. That's the way I like to do it. You could also do it this way. So I need to find things that multiply to 1 times 9, 9, add to negative 6, and the only two numbers that I can find that multiply to 9 and add to negative 6 are negative 3 and negative 3. Now, that gives me this right here. Since this is 1, there is another step to go on if this is not 1. But that's just a little review of factoring. Again, you're probably not going to learn how to factor from this type of video, but there are plenty of resources online to help you with that if you need it. Okay, give this a shot. All right, so in here, the last two questions, they are based on this this information. So Jessica opened a bank account that earns 2% interest compounded annually. Her initial deposit is $100, and she uses the expression 100x to the t to find the value of the account after t years. So in here, they want to find what is the value of x in the expression. So the way to do this, now you should know for this is basically a equals p times 1 plus, I'll put this whole thing here, r over n to the nt. So this is your compound interest formula. Now, we don't have different compounding, so this n value, since it says compound annually, n will equal 1. And so I have a equals p 1 plus r over 1 is just r. 1 times t is just t. This p stands for principal, that's the 100. The t is the time, but I need to figure out what goes in here. And this r in this setup is always going to be the rate, the interest rate, as a decimal. 2% as a decimal is 0.02. And this means that in here we have 1 plus 0.02, which is 1.02, and there is my x value. So 1.02. Now, another way, or some more rationale behind this, some more explanation behind this, is if I earn 2%, that means I have my 100% and 2% more, which is 102%, and that is 1.02 as well. Final question of the test. Give it a shot. Okay, so this is based on the same bank account information from the last question. And Jessica's friend, Tyshawn, found an account that earns 2.5% interest compounded annually. Tyshawn made an initial deposit of $100 into his account. At the same time, Jessica made a deposit of $100 into her account. After 10 years, how much more money will Tyshawn's initial deposit have earned than Jessica's initial deposit? Okay, so let's see, we have J and T. So J will equal 100 times 1.02 to the lowercase t. T will equal 100 times 1.025 to the lowercase t. And I want to find out, I'll make that capital J, what Jessica's account value will be, balance will be, after 10 years. I want to find out what Tyshawn's account value will be after 10 years. So that's basically just 100 times 1.02 to the 10th, or 100 times 1.025 to the 10th. Now let's see how my calculator does with this. So, all right. Okay, let me just check something. So let's do something I know. So I know that 3 to the 4th is 81. Let's make sure I'm doing this correctly. 3 to the 4th is 81. Okay, good, good. So I will do 1.02 to the 10th. So 1.02 to the 10th. And that gives me this. Then multiplied by the 100. And that gives me $121.90. Okay, let's see about Tyshawn. So I'll do 1.025 to the 10th. That gives me 1.28008 multiplied by the 100, which gives me 128.001. Oh, sorry, 0.01. So okay, so round your answer to the nearest cent and ignore the $sign when gridding your answer or your response. Okay, so I will subtract these two. So 128.01 minus 121.90. There's a slight issue with this in that he didn't earn 128, he only earned $28.01. She didn't earn 121, she earned $21.90, but the hundreds are going to cancel out, so it's actually not going to cause a problem for this. So I'm just going to go ahead with it. So 128.01 minus 121.90, and I get $6.11. Now, let me bubble that in, 6.11, 6.11. As a math teacher, I generally like to keep exact answers all the way to the end. So if you notice, I rounded this, I rounded that. But I'm actually okay with that in this case because Jessica's bank is not going to give her a balance that's not rounded to the nearest cent already. Tyshawn's similarly. So in the real world, this value would be rounded, this value would be rounded, and then I'd find the difference. Mathematically, most of the time, I would keep all of my information here and all of my information here and then subtract. It's a lot of times going to give me the same answer, but sometimes it might change. Okay, I hope that helped out. We'll get into a different practice SAT for the next video.